Hi, welcome to the lesson on introducing hypothesis testing. This is a very important lesson for us because for the rest of the semester we're going to be doing hypothesis testing. So make sure you understand the concept here. If you have a little bit of trouble with some of the calculations, that's okay, we can work on that. But I really need you to understand the overall concept, at least. So here's an example we can start with. We've got a random sample of 50 pizza deliveries from a company that claims they deliver in less than 30 minutes on average. So in our sample of 50, we have a mean of 28 minutes for delivery, and if we're assuming the population standard deviation is 5.6 minutes, we want to know, is that enough evidence to suggest that the population mean delivery time is less than 30 minutes? So we know that in the sample, the mean is 28. The question is that enough to say that the population mean is less than 30? So that's why this is a type of inferential statistics, is we're inferring from the sample to the population. Based on this information in the sample, can we say this about the population? So again, hypothesis testing lets us answer questions like these. It is by far the most common tool used by statisticians and in research. Pick up any journal article, and you'll, if it's a quantitative article, you'll find at least one hypothesis test in there. So let's start to pick apart what hypothesis testing is and what it does. So in every hypothesis test, there are two hypotheses. The first one is H naught. So it's H with a sub 0. That's not an O, that's actually a sub 0. So H naught, it's called the null hypothesis. The reason it's H naught, null, this is the hypothesis of no information. The other one is the alternative hypothesis. They'll call it HA or H1. We use these two terms, or the two notations, interchangeably because you'll see them, you'll see both of them different places. That's the alternative hypothesis. That's the one we're wanting to prove. So in a given hypothesis test, you're going to have two hypotheses. There's the one you want to prove, the alternative, and then there's H naught, which is the one that you have to assume unless or until you can prove the alternative hypothesis. So to talk about the concept of hypothesis testing, it helps to think about the criminal justice philosophy. Supposedly, anyway, in the criminal justice system, someone is innocent until proven guilty. If that's the case, these are our hypotheses. In a trial, we're trying to prove the person is guilty, so that's the alternative hypothesis. But what we assume until we can prove the alternative is that the person is innocent. So we assume H naught unless or until we can prove HA. Now, in the criminal justice analogy, just as in hypothesis testing, there's two possible conclusions. If they find the defendant guilty, so if they find that there's enough evidence for the alternative hypothesis, the way they would phrase that is reject H naught, period. There is sufficient evidence to conclude, and then you're going to say whatever it is HA says, which is that the person is guilty. So if they find the person guilty, reject H naught, there is sufficient evidence to conclude that the defendant is guilty. So that's two parts of the conclusion. The part that's saying we reject H naught, and then there's the part that says we have sufficient evidence to conclude, and you're going to say whatever it is that HA says. Okay? You're not going to literally put whatever HA says. You're going to fill in the blank with, in the words of the problem, what the alternative hypothesis says. All right, now there's another possible conclusion too, and that's that the person is acquitted. If that's the case, though, if you think about some cases you've heard about, the burden of proof is always on determining that the person is guilty. What that means is, if the person is found innocent, it doesn't necessarily mean that the jury believes the person is innocent. It doesn't necessarily mean that it's proven the person is innocent. All it really means is there's not enough evidence to say the person is guilty. So for that reason, we never conclude H naught. We never accept H naught. We never say we have proof of H naught. We only say we fail to reject H naught. And that tells us that there is not enough evidence to conclude that the defendant is guilty. So here's that is in writing. So fail to reject H naught. It basically just means we tried to say that the person was not guilty, or that the person was guilty, but we couldn't reject the fact that they were not guilty. So there's not enough evidence to say that the defendant is guilty. These are the only two possible conclusions to a hypothesis test. It's either going to be reject H naught, there is sufficient evidence to conclude. This part is going to change from problem to problem. Or fail to reject H naught, there is insufficient evidence to conclude. And this part might change from problem to problem. But you never mix and match those two parts. All right. A couple other things. We don't ever use the word prove, and we don't state our results conclusively, even if we're rejecting H naught. So we would never say that, reject H naught, we have proven the defendant to be guilty. With hypothesis testing, just like in a court, more or less, we never state anything with certainty. There is either enough evidence or not enough evidence to conclude. But in statistics, we're never 100% sure. So we can only say that the evidence suggests or doesn't suggest, but we can never say we've proven anything. And again, please be aware, we never ever conclude H naught and we never accept H naught because we don't ever have proof for the null hypothesis. All right, so there's 4 steps in hypothesis testing. And we're going to go through each one of these steps in detail. The first step is to set up the hypotheses. The second one is to calculate something called a test statistic, and then something else called a p-value. And I know you don't know what those are yet, but we'll get there. Step 3 is to state the rejection rule, and I'll show you what that is too. And then finally, state the conclusion in the words of the problem, both parts of the conclusion. So let's talk first about setting up the hypotheses. So for right now, we're going to do the z-test. We'll get to other tests later, but for right now, we're looking at the z-test. So for the z-test, there's 3 different possible sets of hypotheses. Mu naught is a hypothesized value. So like for our example with the pizzas, it might be 30. So mu equals 30 versus mu less than 30, or whatever mu naught is. Mu equals mu naught versus mu greater than mu naught, or mu equals versus mu not equal mu naught. Now it may seem a little odd to you that the opposite of less than is not greater than or equal to. In reality, it doesn't matter anyway because we're never concluding H naught. And it's not incorrect to write greater than or equal to or less than or equal to, depending for your null hypothesis. But that's just the way we normally write it. And I'll explain that a little more in a bit. But right now, we've got 3 possible sets of hypotheses. Another thing I need you to know is that the not equal to case is called a two-tailed test. Less than or greater than are called one-tailed tests. You'll need that for when we do this in SPSS next week. All right, so the not equal to is a two-tailed test. Less than or greater than is a one-tailed test. Like I said, we're never going to affirm H naught anyway, so it doesn't really matter. So, like I said previously, the alternative hypothesis is always what we're looking to prove. And the null hypothesis is what we have to assume until we've proven otherwise. So, for example, if the problem says that a researcher believes the mean is more than 50, the alternative hypothesis is going to be mu equals 50. That means the null hypothesis is going to be mu equals 50. So this, the hypothesized value is always going to be the same between H naught and HA. So, some practice setting up hypotheses. So, take a minute, read that, and set up the hypotheses, pause the video, and see if you get it right. And then I'll give you some practice too. All right, so on this one, we want to know if the average price has decreased since 2002 when it was $530. So in 2002 it was $530, so that's our hypothesized value. We want to know if it's decreased, which means we're looking to prove that mu is less than that. So our null hypothesis is then going to be mu equals 530. So that's our first one. Next one. Take a minute and see if you can figure it out. All right, so in this one, we're looking to see if mu is greater than 20. So that means mu greater than 20 is going to be alternative hypothesis, and that means mu equals 20 is going to be our null hypothesis. Last one. We want to know, has it changed? So changed is not a directional word. It means it could be either way, which means that the alternative hypothesis should be not equal to. So then what would be the hypotheses for our pizza delivery example? So if we go back to what that example was, we're looking to prove whether the mean is less than 30 minutes. So that means our alternative hypothesis would be mu less than 30. And that leaves our null hypothesis at mu equals 30. All right, so that's the first step, setting up hypotheses. Second step is to calculate the test statistic and the p-value. Well, let me tell you that every hypothesis test is going to have a test statistic. And that's calculated from the data. It's in terms of the criminal trial, it's basically the evidence. So this, you probably recognize this as coming directly from the central limit theorem, and it does. So you calculate the test statistic as x bar minus the hypothesized value divided by the sigma over the square root of m. By the way, be careful with your order of operations there. I know probably everybody has a different kind of calculator, but you want to make sure that you're doing x bar minus mu naught on the top, and you're doing this on the bottom, and you're dividing the two. Okay, in that order, basically. Most textbooks just call that Z, but I think that's confusing, so I'm calling it Z star for the test statistic. So for that, you just plug in values from the problem. Let me tell you just a little bit about where this comes from. Every hypothesis test is basically a central limit theorem problem in disguise. We're basically determining if the value we calculated is unlikely given our assumption for what the the population mean is. So if the population mean is mu naught, would this value of x bar be unlikely? If it is unlikely, then we'll say that that we would reject the null hypothesis. Otherwise, we would fail to reject. Anyway, we'll come back to that in a minute. So if we plug in values here, in that problem, if you flip back to what the pizza example was, the sample mean was 28 minutes. The hypothesized value was 30. They said that the population standard deviation was 5.6 minutes, and that was based on a sample size of 50. So we've got x bar of 28, mu naught of 30, sigma is 5.6, and n is 50. Now, please try the calculation and make sure that you know how to do it where you end up with the same value that I get here, negative 2.53. Like I said, everybody's got a different kind of calculator, so it wouldn't do me much good to show you how I would calculate it, but make sure you can get this. And if not, let me know. I'll be glad to walk you through it on your individual calculator. So by the way, in this problem, the standard deviation given to us was from the population. So that's going to make this a Z test. We'll do t-tests next week, but so we do that and we get negative 2.53. That's the test statistic, which we're going to use to find the p-value. Now, like I said, we're trying to determine how likely it is to get the sample mean we got given this assumption for our population mean. This is the p-value. So the p-value tells us, is it likely that we would get the sample data we got if the population mean is as the null hypothesis says it is. So that's the p-value. So to find the p-value, we're going to find that in this one, the area below, we want the area below negative 2.53, because this is a less than alternative hypothesis. So we're going to go to StatCrunch, and we're going to the normal distribution calculator. And because this is less than, we're going to pick the less than. And we got negative 2.53. Compute. And that means our p-value is 0.0057. If our alternative hypothesis was greater than, then we'd pick greater than here. If it's not equal to, don't worry about it. I'm not going to ask you to do that. Okay, so if the alternative hypothesis is less than, you'll pick less than here. If it's greater than, you'll pick greater than here. So our p-value is 0.0057. Which again is how likely it is that we would get an x bar as low as the one we got if indeed mu is equal to 30. So the question is that likely? Well, according to the rare event rule, it's very unlikely. Although in each problem, we're actually going to define that possibly differently. But here's how we know. At the beginning of every hypothesis test, the researcher is going to decide on what counts as small. The three most common values for that cutoff point, which is called alpha, or the level of significance. This is a lowercase Greek letter alpha, by the way. It's not an A. But the three most common ones are 0.1, 0.05, and 0.01. 0.05 is the most common. So probabilities that are unlikely will always be below the level of significance. So that means the rejection rule is always, always, always reject H naught if p-value is less than alpha. Okay? So it does not matter what the alternative hypothesis says. This is always our rejection rule, because this always tells us if the probability is unlikely, if it's unlikely that we would get, just know that you'd always reject H naught if the p-value was less than alpha. Okay? If you want to know, I'll be glad to talk to you about it some more. It's a little bit hard to get across in some of these videos, but I think there's enough that we've talked about so far that you can understand. We're looking to reject H naught if it's unlikely that we would get sample data like we got from the given population. If we're assuming the population is the way we are assuming it in H naught. So always reject H naught if p-value is less than alpha. I cannot emphasize that enough. In fact, sometimes I feel like I spend my life saying that. So I actually am such a dork. I got a stamp made that says reject H naught if p-value is less than alpha. So I'm actually going to insist that you show me you know this. So in every problem, I'm going to have you tell me what the rejection rule is. Reject H naught if p-value is less than alpha. So in our example, if the researcher wants to use alpha equals 0.05, then we would say reject H naught if p-value is less than 0.05. If you're ever not given a level of alpha, you can assume 0.05. So in our problem, we got a p-value of 0.0057. That's less than 0.05, which means our conclusion is that we are going to reject H naught and say that there is sufficient evidence to conclude that the population mean, or the mean of all delivery times, is less than 30 minutes, which supports the restaurant's claim. So again, just to reiterate, two possible conclusions to every hypothesis test. Either reject H naught, there is sufficient evidence to conclude that, whatever the alternative hypothesis says, or fail to reject H naught, there is insufficient evidence to conclude that, and then you're going to state the alternative hypothesis. So let's do another example. So the mean weight of all newborn babies, we're supposing, is 7.4 pounds with a standard deviation of 2.3 pounds. So this is telling us this is mu and this is sigma. So if we look at women who are born with gestational diabetes, they tend to have bigger babies. So we've got a sample size of 35, and from that sample, a mean of 8.1. So we want to know then, is the average birth weight of those babies higher than the national average? So we want to know, is it higher than the national average of 7.4? So that means our alternative hypothesis is going to be mu greater than 7.4. And that tells us that the null hypothesis is mu equals 7.4. When we plug in the values, this is going to be x bar, so our sample mean, 8.1, minus the hypothesized value, which always just comes directly from the hypotheses, divided by the standard deviation. They told us in the problem was 2.3, and the sample size was 35. So if we do 8.1 minus 7.4, divide that by this whole quantity here, you should get 1.80. If you go over to StatCrunch, we pick greater than and computed 1.80. So that means our p-value is going to be 0.0359. In this problem, they told us to use alpha equals 0.01. So we're going to reject H0 if p-value is less than 0.01. This p-value is not less than 0.01. That tells us that we would fail to reject H0, which means that there is insufficient evidence to conclude that the mean birth weight of babies whose mothers had gestational diabetes is higher than the birth weight of other babies. So we were not able to conclude that gestational diabetes caused higher birth weights, based on this data anyway. All right, so make sure, go over this problem, practice it, make sure that you're able to get it, so that when you do it on the graded homework, you'll be able to get it right. This is one of those problems I want you to be able to do by hand, because I think it helps you understand a little bit about what's going on with hypothesis testing, especially as it relates to the central limit theorem. So I am going to ask you to do that by hand. However, on problems that you're not asked to do it by hand, you just have to go over to StatCrunch and go to Stat, ZStats, one sample with summary. We had a sample mean of, it was 8.1, standard deviation was 2.3, the sample size was 35. We had a greater than alternative hypothesis, and our hypothesized value here was 7.4. So we just plug in our sample mean, standard deviation, sample size, and then make sure you type in the right value here. For the hypothesized value, pick greater than, less than, or not equal to, and then hit compute. And that'll give you all of this. The nice thing about StatCrunch is that it actually states these for you. It states the hypotheses for you once you type them in, so you can just copy and paste those. There are two ways that you can do a z-test. The one we've used is the p-value method. That's the one that researchers use. So I'm going to stick with that. There is a traditional method using the test statistic, and you'll see that in your textbook, but you can ignore that. The p-value method is easier, plus it's more common, so we'll just stick with it. I need to talk briefly about one other thing, and that's errors in hypothesis testing. So there's two types of errors we could make. We could reject H0, and that be a mistake, or we could fail to reject H0, and that would be a mistake. So if you're looking at the criminal justice analogy, rejecting H0 in error would be convicting somebody when they're actually innocent. They call that a type 1 error. A type 2 error is when you fail to reject H0 and it's not the correct conclusion. And in the criminal justice analogy, that would be the same as acquitting a person who's guilty of the crime. In criminal cases, just like in hypothesis testing, we really try to avoid making a type 1 error. What that means is it's going to be a little more likely that we make a type 2 error, but that's kind of the trade-off. So we try to avoid doing that. And actually, a p-value, another way to think about a p-value is it's the probability of making a type 1 error. So it would be the probability that you would, if you reject H0, the probability that that would be a mistake. So that's actually what you're looking for. That's how the way that's the p-value is it's really saying, given all this evidence, how likely is it that the person could really still be innocent? So what's the probability with all this evidence against the person? What's the probability that all this evidence could pile up against an innocent person? If that probability is low, then we're going to reject H0. Otherwise, we'll fail to reject H0. All right, so I'm going to ask you to do this one by hand, but all the rest of them this semester you'll be able to do in StatCrunch and in SPSS. All right, well, that's it. And as always, please let me know